class of 21. This is question 4. This video will be just question 4 and 5, so they don't get too long and boring. Right, question 4, here it says, it's A star apparently, it's not very difficult. It says, this diagram shows the graph of y equals x cubed minus 3x squared minus 4x plus 12. That'll be quite hard to plot without making huge mistakes even with a calculator. So thankfully it's been drawn for us. Please note it's an x cubed graph. It's very exaggerated up and down. It's essentially one of these beautiful curves that go like that, and there's your up, and there's your up in the other part as well. So that's what we've got, but with all these extra x squareds and x's thrown in, it does add extra bends and twists to the curve. It's essentially a positive x cubed type graph going in that direction as opposed to this direction. Use the graph to solve the equation x cubed minus 3x squared minus 4x plus 12 equals 0. Very straightforward. In other words, y equals 0 where all this graph equals 0. So we're looking for the points of intersection with the line y equals 0 as is usual. So we've got one right there, x equals minus 2. Got one right there, x equals 2. And the last solution is right there, x equals 3. So it's dead easy, isn't it? So let's just list them. We go x equal 1, x equals minus 2, excuse me, x equals minus 2, x equals 2, and x equals 3. There's the three solutions to that equation. And part B was a typing error in the book. It was originally x squared there, so it doesn't make sense to be x squared because it's a different graph. So x cubed minus 3x squared minus 4x plus 12 equals this little lot. In other words, it's been factorized for us, sort of, but we've got to find the values of a, b and c using the graph. Well, very straightforward actually, because we know what the x values are, don't we? If I make this one, so I've got x minus a, if I make that one minus 2, say, put it in there, and that equals 0, because remember, as when you factorize and solve quadratics where it equals 0, y equals 0, you take each part to be 0, because it cuts through the line y equals 0, that's why. We'll solve that in a minute. We'll take the next one, x minus b to be 0, and this time we'll take x to be 2, so we're going to plant a 2 in there, and the next one's going to be x minus c equals 0. We'll take c to be 3, so plant a 3 in there. We've got some little equations, haven't we? And I'll work them out here on the side in a moment. So you're saying to me, well, sir, how do you know the minus 2 goes there and the minus 2 doesn't go, say, in this x position? It makes no difference whatsoever. I could write these little brackets in any order I like. I could have called it x minus b, x minus c, x minus a. It doesn't matter what the value of a, b and c is. What matters is that you substitute one x value in each position of the 3x's shown in the three factors there. And whatever a is and b is and c is doesn't matter. Each one would take a separate value, but you need to calculate it. So assuming minus 2 goes with that first x, I've got minus 2 minus a equals 0. Take the minus over and add it. So I've got minus 2 equals a. So therefore a equals minus 2. That's my first little solution, and I'm sticking to that. Next one, I've got here 2 take away b equals 0. I'll take my minus b over and add it. I've got 2 equals b, so guess what? b is 2, and I'm sticking to that as well. And finally, I've got this one. I've got here 3 minus c equals 0. Take my minus c over and plus it, so 3 equals c, and therefore c is 3 by logical deduction. That's all there is to it. So my value of a is minus 2, my value of b is 2, my value of c is 3. Just 5. The diagram shows part of the graph of y equals 4 to the power of x. There it goes powering off in the positive direction there. Again, very, very hard to plot negative powers because we're talking about quite small fractions, and on a grid that goes from 0 to 1 with 5 little squares, and again, likewise for the x-axis, it's very difficult to plot it accurately, so they've not bothered either. So I've got the graph of y equals 4 to the power of minus 5. Well, minus 5 is going to be where x is minus 5. So I'm going to try and read what the y is going to be now. Very, very difficult. Again, let's just use this facility here. So 0.5 minus 0.5 is there, and there's my solution there. It looks like about 0.5 or 6. Again, I'm going to be honest with what I can see. I can see that it's about 0.6. So I'm going to say therefore that y equals 0.6. Here I've got y equals 4 to the power of 1.5. That's a little bit better, which means I can do this and get a half decent answer, or about there I'm guessing. It's not perfect, is it? So I'm going to do that and just make it look pretty. So I've got 1.5 then on the x, hit my line, my function, turn left, and there it is. So I've got y equals approximately 8, and now I've got y equals 4 to the power of 3/4, or 0.75. 3/4 about here somewhere. Again, it's going to be a real pain to try and do it. So I'm guessing about there. I really am guessing about there. And turning left. Show the examiner what the brain did. Up and left. Oops, up for you as well. I've got about 2.2. So in terms of, I'm sure I can calculate that easily using a calculator because it's Unit 3. But I'm asked to use my graph to do that honestly. So 2.4, I think I said it was going to be. 2 squares, 0.4, yeah. This time we're working backwards. We've got what y equals 4 to the power of x, and therefore I've got to draw on the line y equals 0.5. Again, quite hard to judge this. So 0.5 is going to be about here. So, it's almost this one repeated, isn't it? So I'm going to go with minus. I'm going to go with minus 0.5. So x equals minus 0.5. And as you can see, the first question was y equals 4 to the power of minus 0.5. I read as y is 0.6. This time they're giving us y as 0.5, which is really, really close. So hence it's not surprising I'm getting an answer of a power of minus 0.5. You know, so I've used this little arrangement interchangeably. Alright, so that's that one done. Y equals 4 to the power of something, and 4 to the power of something is 1. So here I go. This is really, really easy. I want the line y equals 1, and there's the line y equals 1 straight across there. I will draw this one in just to make a point. Drop it back there somewhere, and as you can see, it intersects the graph right there on 0. You know that any number to the power of 0 is 1. So you can see it on the graph there. So when I've got the line y equals 1 drawn in, it intersects the curve at 0. So there it is. So what is x going to be? X is 0, because 4 to the power of 0 is 1. And now I've got y equals 4 to the power of x, and therefore I've got to plot the line y equals 5. So I'll draw this one in as well. Put it about there somewhere. Label up. Y is 5, and draw down. See what I can do. So plant it right there, I'm guessing. Right, I'm going to go for 1 point. Goodness knows what, I don't know. Oh grief, I can't tell. 1.2 perhaps. Let's just go for 1.2. That's the best I can do. So therefore x equals 1.2, maybe 1.1. 5 squares or 10 squares? 1, 2, 3, 5 squares. So it's 1 square. I'm going to go for 1.2, and that's it. It does say, after all, use your graph to solve the following equations and use your graph to estimate. So that's the best we can do by reading off it, and that's good enough for grade A star. I don't know why it's A star, we're just reading off a stupid curve, but that's it, and I'll then do the last assess video with the remaining 2 questions.